Okay, and that is how you do a frequency distribution table. We're going to move on to bar graphs and histograms. This is an example of a bar graph. Infertility incidence. This is a bar graph describing infertility among women who have never had children. Okay, at the bottom you have the variable called age, and it's broken up into three classes: 15 to 24, 24 to 30, 25 to 34, and 35 to 44. Notice that each class is exactly a width of 10. That has to happen when you create bar graphs. Your class width, which can come off of a frequency distribution table, has to be the same for every grouping. The height of the bar represents the percentage of women who are infertile. So we have, let's see, we're looking at a frequency on the vertical axis that starts at 0 and goes up by increments of 5. Now the first bar here looks like it's about as high as 5, maybe a little bit, okay, it's 4. It's a little bit lower than 5. So that's why there's a 4% above that bar. Okay, the height of the bar here, it looks like it's below 15, somewhere between 10 and 15, and the bar tells us that it's exactly 13%, and the grouping for 35 to 44, 21%, which is a little bit more than 20. Okay, and we look at the source, National Center for Health Statistics survey 8,500 women. So this is a sample of 8,500 women. Incidence represents those who know they are infertile or have had difficulty conceiving. Okay, so we're looking at a sample of data, and we don't see the specific data values when we look at a bar graph. All we see are the groupings. Okay, so a bar graph is generally used to depict discrete or categorical data. A bar graph is displayed using two axes. One axis represents a discrete or categorical variable, while the other axis usually represents the frequency for each category of the variable. Okay, so we have here our discrete variable called age, grouped from 15 to 24, 25 to 34, 35 to 44. And on the vertical, we have the frequency, and this is in terms of percentages. A histogram is a vertical bar graph that represents a continuous variable. To depict the continuous nature of the data, the rectangles are connected to each other without any gaps or breaks between two adjacent rectangles. The histogram can be built from a frequency distribution table. So notice that in this column, we're looking at temperature in degrees Fahrenheit, but it's categorized in a way that makes it look like it's discrete. If we look at the class boundaries column, now we have data that appears that it could be continuous. Now this column, the class boundaries column, is the column that we use to create the histogram. Okay, because the histogram is made to represent continuous data, and so we use the class boundaries column, which represents continuous data. And here's an example of what a histogram looks like. It's different than the bar graph because the bars are not separated. They're flush against each other. Notice that the horizontal axis contains class boundaries. Okay, it starts at the lowest class boundary, which is 79.5. Oh, there may be a little error there. That's okay, this is just for demonstrative purposes, but I'll show you how to create a histogram from data from scratch in a minute. Oh, I'm sorry, it's just a little hard to see. That says 73.5. Okay, it's just hard to see. 73.5 77.5, 81.5, 85.5, 89.5, 93.5, 97.5. So that horizontal axis is labeled so that it appears like the class boundaries. 73.5, then you make another notch for 77.5, and make another notch for 81.5, another notch for 85.5, another notch for 89.5, and another notch for 93.5. Now, you don't put the ending boundary, you just put the single number, the single class boundary, because it's continuous. Notice that there's this jagged line here. The jagged line indicates that there's a lot of space between 0 and 73.5 that we're not accounting for. That jagged line is to indicate all that empty space. And then the frequency is on the vertical axis, and here we're marking our vertical axis by 2. In this case, it doesn't represent percent, it represents frequency. The 6 rectangles in the histogram represent the 6 classes in the frequency distribution table. Okay, so however many rows you have in your frequency distribution table, that is however many rectangles you're going to have in your histogram. The width of each rectangle, for example, if you look at the first class boundary that goes from 73.5 to 77.5, is a width of 4. So that's the class width that comes from the frequency distribution table. So the width of each rectangle is the same as the class width from the frequency distribution table. You can easily find a class width by looking at class boundaries and subtracting consecutive class boundaries. So looking at these class boundaries, I can see that if I wanted to find the width, all I had to do was subtract 77.5 minus 73.5, or 81.5 minus 77.5. The height of each rectangle is its frequency, the class's frequency. The vertical sides of each rectangle are class boundaries of each class. Okay, so if we take a look at the very first rectangle, it's got a class boundary that goes from 73.5 to 77.5. Okay, we're going to construct a histogram on the calculator. Okay, we're going to use the data that we already put in the calculator earlier, which is the amount of time 50 students need to complete the final examination. And these were the values we put in our calculator in L1. We're going to construct a histogram using 7 classes. Now you don't have to create a frequency distribution table first, but it is very helpful. Okay, so we're going to enter the data in our list, which is already in L1. And we're going to set the window as follows. So I'm going to run through these and then I'm going to go to the calculator and show you. The window min, x min, should be the smallest class boundary, which in our case is 9.5. The x max should be set to the largest class boundary, which is 121.5. X scale should be set to the class width, which we found was 16. Y min is -5, and the reason for this is so we have some room at the bottom of the visual display on the calculator to see the information. Y max is your estimate of the frequency of the largest class. We can always come back to these window settings and adjust them if our graph does not appear properly. Y scale and X res should be kept at 1. So let's go to our calculator. Okay, we're going to go to the window key, which is right here, window. We're going to set X min to 9.5. That is the smallest class boundary. X max 121.5. That's the largest class boundary. X scale is 16, the width. X min, -5, we're going to put in a negative which is right here. It's not the same as minus 5. What this lets us do is, I'll show you visually what happens when you put in a negative 5. You'll have some space at the bottom of the screen so you can see the text that appears. Y max, our estimate for the largest frequency. If you're not sure what this is, like let's suppose that you have not created your frequency distribution table yet, you can give this a guess. You could always come back and adjust it if the bars of your histogram get cut off. Y scale X res will stay at 1. Now notice that there's an arrow here, which means that you can go down a little further. You're not going to have to adjust this. You can leave that as is, whatever it is on your calculator. Just make sure that you set the X min, X max, X scale, Y min, and Y max. Okay, we're going to set the graph type now. So I'm going to run through these and then I'll go to the calculator and show you. Second stat plot, we're going to choose number 1. Make sure the on is set. For type, we're going to click the histogram picture. We're going to specify L1 as our list. Frequency is 1. Okay, so let's open up the calculator and show exactly how this works. Okay, we've just set our window. What we want to do is go to the stat plot menu, which is in blue above the Y equals key. So we'll hit second, Y equals, or stat plot. What you should have here are 3 plots. Turn the first one on if it isn't on already, and turn the other 2 off. This is how you can do that. With one highlighted, hit enter, and at the top here you see the on is black, it's highlighted in. If it's not for you, press enter when your cursor is on it. If ever you want to turn a stat plot off, go to the off by using your arrow right and hit enter on that. Okay, so now it's off. I want it to be on, so I'm going to do that. Now, I want the other plots to be off. If your other plots are on, use your arrow up and arrow to the right, plot 2, hit enter, and make sure that you highlight off and hit enter to turn it off. Go up and do the same thing with plot 3. Hit enter and make sure that it's set to off. Okay. Okay. So going back to plot 1, which should be the only plot that's on, you're going to use your arrow down key to go to the type of graph. Now we have 6 types of graphs here. The one that we're going to do is the histogram looking graph. So use your arrow down key to go to type, and now use your arrow right key, right to go to the histogram, and press the enter to set it. Go down using your arrow down key, go to X list, and make sure that this is L1 where your data is. If your data is not in L1, you can use your list keys down here to change that list. So if my data was in L2, I can change it to L2. But I'm going to keep it at L1. Okay, if you make an error like this, just use your arrow back key and hit DEL for delete, and it will delete any problems you have. Frequency should stay at 1. Okay, so to set up the histogram, we did 2 things. We set the window. Sorry, that's not what we want to do. Quit if you ever find yourself in a menu that you don't know exactly what you're doing. Hit window. So we set our window, and then second stat plot, we set up our stat plot number 1 for a histogram using L1 as the data. That's enough to set it up. Now we're going to go press the graph button, and this is our histogram. Okay. Now notice that the very tops of the rectangles are not chopped off. They are visible. Now if we press window and we make this Y max, because remember it was a guess before, your estimate for the largest class frequency. If we made it too small, for example if it were a 10, look at how the tops of the rectangles get chopped off. So you can go back and make that 15 again. 15 is enough to look at it nicely. Now that -5 for Y min is what gives us this empty space down here. Now that empty space is useful because now with the histogram on our calculator, I want us to trace the boxes. So we hit this trace key here, which is above the arrows next to the graph button. So hit trace, and notice what happens here. I have a blinking cursor on the very first rectangle. I have a text at the bottom of the screen that's visible because I set Y min to -5. If Y min were set to 0, then this text would appear on top of the bars, which is not easy to read. So we have a min of 9.5, a max, it says less than 25.5. What that's telling us is that our class boundary for this first class goes from 9.5 to 25.5. The less than means that any data value that is anywhere from 9.5 to anything less than 25.5 would be placed in this first class. N equals 1 means the size of the frequency for that first class is 1. Now this should verify exactly what we have in our frequency distribution table. And if it doesn't, then you'll want to go back and either fix the settings here on the histogram, or maybe you made an error in the frequency distribution table and you have to fix that. To travel across the histogram, you're going to use your arrow right key. Arrow to the right, and now it's flashing on the second class, which goes from 25.5 to 41.5, which should correspond exactly to the class boundaries for the second class. N equals 6 should correspond to the frequency of the second class. And if you use your arrow right, you can go through every bar in the histogram. So all 7 bars are visible, which is important. We wanted to make that X max large enough to see the very last class, which is 105.5 to 121.5 with a frequency of 1. So using the calculator's histogram feature is a great way to verify that your frequency distribution table was created properly. Okay, notice that as you move your cursor across the histogram, the frequency and class boundary of each class is displayed at the bottom of the screen. Okay, to copy your finished graph on paper, you give your graph a title, you label the axes, those are the vertical and horizontal axes. Frequency would go on the vertical axis and the variable would go on the horizontal axis. We mark the horizontal axis with class boundary values. We mark the vertical axis with frequencies. And then we indicate with a jagged line the missing data values on the horizontal axis. So let me give you an example of what we have to do. we create a rectangle for each class whose height is the class frequency. So our frequency distribution table, the title could be Histogram, time needed to complete a final exam. So we give it a title. We label the two axes, frequency on the vertical and minutes on the horizontal. We label the vertical axis. I am labeling in increments of 2. So 2, 4, 6, 8, 10, 12, 14, 16. Do whatever is appropriate for the data values in your data set. Maybe it's more appropriate to label by 10s. Maybe it's more appropriate to label by 1s or by 5s. You would figure this out by looking at your data values and deciding what's the best scale. On the horizontal, we're going to put our class boundaries. Now, it's important here that your class boundaries are labeled at the beginning of each rectangle and at the end of each rectangle. So 9.5, 25.5. Don't put another 25.5 right next to it. It's just one 9.5, 25.5, then 41.5, then 57.5, etc. It's not like a bar graph in which you would put a range of values beneath each bar. They should be labeled like units on a horizontal axis. So you're going to do this for all the class boundaries up until 121.5, and then you're going to create rectangles the height of each frequency. Then you make that little jagged line here to indicate all the space between the very start, which is 0, and 9.5, because there's space there that we have to indicate we're accounting for. And that is your histogram. Okay, so you can use a frequency distribution table and histogram together. Oftentimes they can be used to verify one another to make sure you did your work correctly.